Okay.
29 people have not yet given your assignment. Okay, I told you yesterday was the last date. We will send a mail, don't worry, after the class. Okay. Now, so today, we have discussed about various problems, isn't it, on the Brayton cycle. Couple of Brayton cycle were ideal in nature. Couple of Brayton cycle had that a deviation thing because of the efficiencies, and we have found out all the variants of all the Brayton cycle. Now, we have discussed some of the methods through which I can improve my efficiency and the work output, isn't it? There are three methods. One is the regenerative gas turbine method, second one is intercooling, and third one is the reheating process. So based on that, even the problems could be asked in an examination. So we will solve one by one. So today we will solve about the regenerative gas turbine problems. Okay. Now, what is the change? I will let you know. All procedure remains same, except there are few more additional formulas for the regeneration effectiveness we will come across today. You will learn today, don't worry. Now, regenerative gas turbine cycle, air enters at 1 bar. So he says regenerative, no? First to draw a Brayton cycle. For regenerative analysis, just a TS diagram is more than sufficient. Okay, TS diagram is more than sufficient. Don't go with the TT diagram. Just TS is more than sufficient for you. Okay. Now, this. So TS diagram, how it would look? It would look something like this, right? So the process 1 to 2, 2 to 3, 3 to 4, and 4 to 1. So all this process, you know it very exactly. Now, this is a regenerative cycle. Now, air enters the compressor at 1 bar and 15 degrees Celsius, he says. So what should I take? What are these values? Air enters the compressor at 1 bar and 15 degrees Celsius. So what are these values?
P1.
Pressure.
Right? It is just P1. That is equal to how much? 1 bar. And T1, 15 plus 273, 288 Kelvin. Okay. The pressure ratio is 6. What do you mean by pressure ratio? It is the
P1 by
value of
P2, beta.
beta, which is given, which is nothing but P2 by P1. P1 by P2 alla. P2 by P1 equal to P3 by P4. That is equal to how much? 6 he has given. The isentropic efficiencies of compressor and the turbine are. So efficiency of compressor is 0.8. Efficiency of this 0.85. So when he has given the values of efficiencies of compressor and as well as the turbine, what you are supposed to do?
2 dash and 4 dash.
Exactly. So the deviated path you have to draw to meet at 2 dash and meet at 4 dash, something like this. Okay. No. Next. The maximum temperature in the cycle is 800 degrees Celsius. So what do you mean by maximum temperature in the cycle? So which one is the maximum temperature? Which one is the maximum temperature?
P3.
So I would just write T3 is equal to how much? 800 plus 273 is 1073 Kelvin. The regenerative effectiveness is 0.78, he says. So regenerative effectiveness, you'll come to know what is that exactly. Just write effectiveness is indicated by this particular symbol of a regenerator. Effectiveness of this particular regenerator is how much? 0.78. So since he has specified that there is a regenerator in the system, so there would one more state point to come in middle of this after 2 dash, which is 5. Getting it? what happens when the regenerator is specified? One more state point would come in the middle of the heat addition, which is state 5. Understood, everyone? What happens when a regenerator is placed or regenerator effectiveness is given, or it is a problem on a regenerator? What happens? What the necessary changes that you have to make in the TS diagram? Yes?
Extra state.
So you have to incorporate an extra state 5 in between 2' and 3. So that is the primary change that you have to make. That's fine. Next, assume the values of Cp. So Cp he has asked us to assume how much? 1.1 kilojoules per kg Kelvin, and gamma value is equal to how much? 1.32 for combustion products. So find the cycle efficiency. So he's asking what? He is asking us to find the efficiency of Brayton cycle. So this you have to find. Okay. Shall we proceed with the solution? Yes. Shall we start the solution? Are you ready? Are you ready, guys? Shall we start the solution?
Yes, sir.
Yes, sir.
So solution here. Okay. For solution, what do you have to find? Go with that. Efficiency of Brayton cycle you have to find, isn't it? So how to calculate the efficiency of Brayton cycle? Anyone?
W net divided by QC or 1 minus 1 divided by beta raised to gamma minus 1 upon gamma.
Okay, so any one of these two expressions you can use. So in this case, in the efficiency of regenerator is also specified, isn't it? So that's why what we will do is we will use W net divided by the heat supplied. So what is W net, by the way?
Work done
WT
of
plus WC.
It is WT plus WC divided by heat supplied. Now, let me write all the formula to have a clarity about this particular problem, how we are going to proceed. So, how to calculate WT now?
MCP
M into Cp into
T1 minus T2 dash.
WT.
T3,
T3 minus of
T4 dash.
T4 dash. Next, WC now. MCP into, as we told, it is T1 minus of T2 dash. Very good. Now, how do you calculate QS?
MCP into T3 minus T2 dash.
mCp into.
T3 minus T2 dash.
So for heat, it is final minus initial. So final state is T3 and initial state is not T2 dash, but it is T5. Please do remember this. This is the only change in the problem. Okay, if you want, you can highlight it using an highlighter. Okay, so this is the only change in this particular problem. So you were all right in saying that generally what we used to take during the heat supplied we used to take from T3 to T2 dash, isn't it? Whatever the heat is supplied, we were accounting from T3 to T2 dash. But because of the regeneration, what you have to do, you have to just take from T5 to T3, because this T dash to 5 is there. No, this small amount of heat is gained because of regeneration. That is not heat supplied there. The heat is supplied only in 5 to 3. Heat is supplied from state 5 to state 3, additional heat for every cycle. So that's why you have to consider only this. So this is the only change in this particular problem. Understood, everyone? Understood? Any doubt?
Yes, sir. Yes.
So come on, you should be very fast in calculating WT and WC, since it is again a repetitive procedure, no new thing in it. So be fast in calculating WT. So WT is given by, again it is mCp into T3 minus T4 dash. So I don't have T4 dash. So in order to calculate T4 dash, I require T4. So how do I calculate the T4? How do I calculate the T4? Yes, Pvt conversion equation. Pvt conversion equation there. Okay. So for which process you are going to apply? You are applying it for 3 to 4. You are applying it for 3 to 4, which is adiabatic expansion. So for adiabatic expansion, what is the Pvt conversion equation? It is P3 by P4, that is equal to V4 by V3 whole to the power of gamma, that is equal to T3 by T4 whole to the power of gamma divided by gamma minus 1. Now P3 by P4, you are directly taking it as beta. Now T3 by T4, you are going to substitute here. That is equal to T3 is how much? T3 is 1073 divided by T4. That is the value you are going to get. And the gamma value which is given is 1.32 divided by 1.32 minus 1. And the value of beta which is given is 6. So from this, what is the value of T4? That you will get it in Kelvin. So once you get T4, next you go on to calculate the T4 dash. So in order to calculate T4 dash, what you have to do? You have to use the efficiency of turbine equation. So efficiency of turbine is nothing but it is actual work divided by isentropic work. So actual work is mCp. Actual in the sense you will get a dash there. So it is T3 minus T4 dash. Isentropic or ideal or theoretical in the sense you will not get any dash there. So these two will go away. The remaining I would just write it as T3 minus T4 dash divided by T3 minus of T4. Correct me if I am wrong. Okay. So efficiency of turbine is given as 0.85. So that is equal to T3, which is given as how much? 1073 minus T4 dash you need to find divided by T3 is again 1073 minus T4. How much is the value of T4?
694.955.
694.9. So 694.9. From this, can you give me the value of T4 dash and hence the value of WT?
$751.66.
751.66 is the value. Good. So with this particular value, let us calculate any parameter which is given with respect to mass. Mass ಬಗ್ಗೆ ಏನಾದರೂ ಕೊಟ್ಟಿದ್ದಾರಾ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ? mass flow rate ಏನಾದರೂ ಕೊಟ್ಟಿದ್ದಾರಾ? Check. No. So consider it for a unit mass basis. Okay, we are doing this because you are considering it for unit mass basis. I think the value of Cp is given. The value of Cp is 1.1 into the value of T3 is 1073 minus T4 dash is 751.66. So check for the unit. Cp is in kilojoules per kg Kelvin. Cross temperature value would be in Kelvin, so Kelvin goes away. Whatever the value you get, you will get 10 kilojoules per kg, and kindly give me this value.
353.47.
353.47 is the value. Just check. So I immediately go for calculation of WC. So WC is given by again mCp into T1 minus of T2 dash. So you don't have T2 dash there. In order to find T2 dash, you must depend upon T2. So in order to calculate T2, you have Pvt conversion equation for 1 to 2, which is adiabatic compression. For this, you have Pvt conversion equation given as P1 by P2, V2 by V1 whole to the power of gamma, T1 by T2 whole to the power of gamma divided by gamma minus 1. So P2 by P1 is beta. So P1 by P2 is 1 divided by beta. Next, temperature, that is equal to T1 as 288 Kelvin. T2 you are supposed to find out. Gamma value is 1.32 divided by 1.32 minus 1. Beta value is 1 divided by 6. So from this, what is the value of T2 that you are going to get in Kelvin? So once you get T2, what you have to do again, go with the efficiency of compressor equation. It is ulta. Here it is isentropic work divided by actual work. Now, isentropic work, again it is mCp into, for compressor it is T1 minus T2. Even this is also mCp into T1 minus T2, but the thing is, because it is actual, you will get a dash there. So this 2 will go away. The remaining ones I will write here. It is T1 minus of T2 divided by T1 minus of T2 dash. Now, efficiency of compressor is given as 0.8. That is equals to 288 is the value of T1. What is the value of T2?
444.66 Kelvin, sir. 44.66.
444.667. Just check the value. So it is 288 minus of T2 dash. So from this, the value of T2 dash, you will get as how much?
483.83.
483.83. Is that correct? Everyone are getting the same value? Just check the value. So once you get it, take the same old equation there. So WC is equal to so considering it for unit mass basis, so it is Cp into T1 minus of T2 dash 1.11 ಏನೈತಲ್ಲ 1.1 ಅಷ್ಟೇ. Okay, into T1 288 minus 483.83. So from this, whatever the value you get, it would be in kilojoules per kg. So after that, calculate net work done, which is W net WT plus WC. WT value was 353.47 minus of, what is the value?
Minus 215 plus 0.41.
Minus 215.41. 215.41. So what is the value of W net? And again it will be in kilojoules per kg.
$138.06.
130 point how much?
138.06.
138.06. So until this particular point, everything what we have calculated was already done in all previous problems. The same steps we have repeated it. Now, so now you need to calculate the value of QS. So QS is given by what? It is MCP into T3 minus of not T2 dash, but here it is T5. Okay. For that, he has given us a clue of this one, effectiveness of a regenerator. So what is that? So here you need to find out T5 now. In order to calculate T5, you have effectiveness of a regenerator. later. So what it is, what do you mean by effectiveness of a regenerator? It is the ratio of actual heat transfer divided by maximum. It is already there in your notes. Okay, I have explained this regarding in the theoretical classes. Possible heat transfer. Now, next, what is actual heat transfer is, which is happening, which is T3 minus of T5. So this is the actual heat transfer which is happening. Okay. What is the maximum possible heat transfer? What is the maximum possible heat transfer? It is mCp into T2 dash minus of T4 dash. So this is the maximum possible heat transfer. So effectiveness of a regenerator is specified as 0.78. Anyhow, MCP will be going. Just substitute the remaining, so 0.78 is equal to the T3 value is how much? Minus of T5 we have to find out, divided by, what is the value of T3? Oh, sorry, what is that? T3, how much is the value?
1073.
Hey, this is not T3, man. Sure. It is T2 dash. What is the value of T2 dash?
$483.83.
483.83. T2 dash. Correct, huh? Okay. Next is T2 dash is again 483.83 minus of T4 dash. How much is the value of T4 dash? $751.66. 751.66. Just check the value. If the value is right, you can go with this, or else you may have to reverse this. Okay, let us see. What is the value of T5?
692.73.
Okay, acceptable. 692.73 Kelvin is the value of T5. So once T5 is known, QS can be calculated. mCp into T3 minus of T5. So considering it for unit mass basis, considering it for unit mass basis, so it is 1.1 into T3 value is 1073 minus T5 value is 692.73. Okay, that is equal to, what is the value of QS? Whatever you get it in kilojoules per kg.
418.29.
418.29. So last, which was asked, is the efficiency of Brayton cycle, for which we have done so many calculations. It is just W net divided by QS. W net is how much? W net 138.06. 138.06. So remember, when you are substituting this, both should be of the same units. It is of the same units, which is kilojoules per kg. Now, if you do into 100 for this, you'll get it in percentage. So what is the
33, sir.
value? How much? 33%. Any doubts in this particular problem? Let me know. Any doubts? Any doubts?
ಸರ್ ಅದು ಎಫಿಷಿಯನ್ಸಿ ಆಫ್ ಬ್ರೇಟನ್ ಸೈಕಲ್ ಅದು ಮತ್ತೊಂದು ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿ ಸಹ ಫೈಂಡ್ ಮಾಡ್ಬೋದಲ್ಲ ಸರ್?
ಅದರಲ್ಲಿ whether it is cumulative of your regenerator.
ನೋ ಸರ್.
ರೀಜನರೇಟರ್ದು ಏನಾದರೂ ಅದರಲ್ಲಿ ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಇದೆನಾ?
ಇಲ್ಲ ಸರ್, ಇಲ್ಲ.
ಇಲ್ಲ ಅಂತಂದಾಗ ಆ ಫಾರ್ಮುಲಾ ನೀನು ಯೂಸ್ ಮಾಡಿದ್ರೆ ನಿಂಗೆ ಅಕ್ಯುರೇಟ್ ರಿಸಲ್ಟ್ ಬರಲ್ಲ. ನಿನ್ನ ರೀಜನರೇಟರ್ ಕನ್ಸಿಡರೇ ಆಗೋದಿಲ್ಲಲ್ಲ.
ಆಯ್ತು ಸರ್, ಆಯ್ತು. ಅದು ಅದೇ ಹೋಮ್ ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಅದು ಡಿಫ್ರೆಂಟ್ ಆನ್ಸರ್ ಬರ್ತದೆ ಸರ್ ಎರಡು ಫಾರ್ಮುಲಾದಲ್ಲಿ.
ಡಿಫ್ರೆಂಟ್ ಆನ್ಸರ್ ಬರ್ತದೆ, ಹೌದು, ಅದು ಸತ್ಯವಾಗಿ ಬರ್ತದೆ, ತೊಂದರೆ ಇಲ್ಲ. ಕೆಲವೊಂದು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಸೇಮ್ ಬರ್ತದೆ, ಕೆಲವೊಂದು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಡಿಫರೆಂಟ್ ಬರ್ತದೆ.
ಓಕೆ ಸರ್, ಓಕೆ,
ತೊಂದರೆ ಇಲ್ಲ. ಎನಿ ಅದರ್ ಡೌಟ್ಸ್ ಯು ಹ್ಯಾವ್? ಪ್ರಾಬ್ಲಮ್ಸ್ ಈಸಿ ಉಂಟೇನ್ರೋ ಇಲ್ಲಿವರೆಗೂ ನಿಮ್ಮ ಇಂಟರ್ನಲ್ಸ್ಗೆ ಇರ್ತದೆ, ಅರ್ಥ ಆಯ್ತಾ? ಸೊ totally there would be 6 questions for your internals. Let me stop this.